Welcome, geometry students, to the homework out video or the review sheet out video. Let's go ahead and get started with these problems and see how you guys do today, okay? Let's take a look at numbers 9 through 12. Name the special segment of the triangle, okay? Well, notice on number 9 that we have a segment that runs from the vertex to the opposite side in such a way that it's perpendicular. Now notice there's no mark here and there's no mark here. So we don't know for sure that this point here is the midpoint. We don't know that. The only thing we know is it comes from the vertex and it's a right angle. Well, that's called an altitude, guys. Okay, that's called an altitude. Alright, moving on to number 10. Okay, now notice here the only thing we know is this big angle right here is cut in half. This angle here is congruent to this angle here. We would call that an angle bisector because the angle is cut in half. Okay, number 11. The only thing we know here is that the segment comes from a vertex. It's this point right here, so that this side here is congruent to this side here. Notice we have a mark here and a mark here. So we call that a median. A median. Okay, and then lastly, number 12. Notice that we have a line drawn inside a triangle so that it hits the midpoint. We know that because this side here is congruent to this side here and it forms a right angle. We call that a perpendicular bisector. Okay, the segment is perpendicular and it bisects. So perpendicular bisector. Okay, number 13. Now, on numbers 13 through 16, we're going to name the point of concurrency. Now, concurrency means the point where all three lines intersect. So we don't know what that point is called until we first decide what each one of these lines are right here. Okay, so if you'll look, all of these lines are angle bisectors. Okay, this big angle here has been cut in half, this angle here has been cut in half, and this angle here has been cut in half. So what do you call this point when you have three angle bisectors that are intersecting? Well, they're going to intersect. So what do you call this point where your three angle bisectors intersect? Well, you need to know this for the test. It's called the incenter. Okay, number 14. Now here we have Okay, they've made a mistake here in the book, guys, and I hope you caught this. I really hope you did. These are supposed to be perpendicular bisectors, and there's no mark. Like this side here should have a mark, and this side here should have a mark. I'm looking in the book to see if they say something. Yeah, that's not good. And this side here should have a mark or two marks, and this side here should have two marks like this. And then over here, this side here should have three marks, and this side here should have three marks. All of these lines here are perpendicular bisectors, okay? And so, what do you call this point here, where the three perpendicular bisectors intersect? Well, if you're looking at your notes, it's called the circumcenter. Okay? Alright, number 15. Okay, here we have medians. All three of these lines are medians. So what do you call the point where three medians intersect? We call it the centroid. Okay? Alright, moving on to 16. Here we have altitudes. We have a line drawn from the vertex to the other side so that we have a perpendicular line, or a right angle, excuse me. We have three altitudes. So what do we call this point where three altitudes intersect? Well, we call it the orthocenter. Okay? Alright, moving on. Number 17. A triangle has these vertex 5, 4, -2, 3, and 2, -1. Okay? Now what they want us to do is they want us to find the slopes of its mid-segments. Well, students, please think about this for a second. If I drew a mid-segment from here to here, isn't it parallel to this line? So the slope, I'll put m. Remember, m stands for slope. The slope of this line here is the same as this line here. So I'm just going to find this slope here. Okay? If I drew a mid-segment from, so I'm going to find this slope right here. Okay? Put an m right here for this one. We'll call it m subscript 1. Now, if I were to draw a mid-segment from here to here, it would be parallel to this line here. So if I wanted to find the slope of this line, I would just find the slope of this line. Same thing. So I'm going to call this slope here m subscript 2. And then lastly, if I drew a mid-segment from here to here, that line would be this slope here, would be the same as this slope here. Okay? So I'm going to find the slope here. And here we go. We better put our points up here so we can recognize them. This is B, this is A, and this is C. So if I want to find the slope of M1, I would use points B and C. Points B and C. Y minus Y. X minus X. Josh, you have one extra. Okay, so we end up with -1. So there's one of my slopes of my mid-segment. Okay? Let's take a look at slope number 2. Slope number 2 is right here. We're going to use points B and A. B and A. So here we go. Y minus Y. 4 minus 3. X minus X. 5 minus a -2. That would give me a 1/7. 1/7. Okay, let's find our last slope. Slope number 3, and it's going to be points A and C. Okay, A and C. So we would have 4 minus a -1, and X minus X would be 5 minus 2, which would give you 5/3. Pretty simple. Okay, moving on to number 18, or no, yeah, number 18. Okay, now they're going to give us the midpoints of the sides of a triangle, and they want us to find the coordinates of the vertices of the triangle. So here we go. 2 -1, 0 -3, and -1 1. Now that's the midpoints, okay, of a triangle. Now students, this is a really difficult problem, and there's a very good chance I'll give you one of these on your test, so please pay close attention, okay? Now, if these are the midpoints of your lines, then you know for sure you have a line that goes like this. And you know for sure you have a line that goes like this. It's got to be the line that goes to this point has to be parallel to these 2 points here, so kind of like this. And you know you have a line that goes to this point parallel to these 2 points here, so kind of like this. Now notice what I did here, guys. Here's your midpoints. I'm going to connect your midpoints. Notice I drew this so that this line here was parallel to this line here. This line here is parallel to this line here, and this line here is parallel to this line here. Okay, it's very important you understand that, okay? So here we go. First of all, I have to find this. We'll start with finding this line right here. Now, if I want to find this line here, it's going to be parallel to this line here. So let's find the slope real quick. I go over 2, 1, 2, and up 2, 1, 2. So to draw this line, I'm going to go over 2, up 2, over 2, up 2, and then down here I'll go down 2, over 2, down 2, over 2. Okay? And that gives me a pretty decent line. Okay? I'm going to highlight those points really big so I know where they're at. Or not really big, but with a different color. Okay, now let's do the same thing over here. If I want to find this line here, it's going to be parallel to this line here. Okay, so let's find the slope. From this point here, I go up 2 and then over 3. So from here, I'm going to go up 2 and over 3. Nailed it right there. Okay, then up 2 over 3. Now we'll go the opposite, down 2 over 3. Down 2 over 3. Okay, so there's my line. So it looks like I've found one vertex of the triangle already. Okay. Okay, now if I want to find my last side here, it would be, I should have kept this point red so I know where my midpoints are. There we go. If I want to find my last line, it will look like this. Something like that. It'll be parallel to this line here. Okay, so find the slope here. Over 1 and down. So we'll go over 1 and down 4. And this is what I thought, it hits right there. And then we'll go up 4 and over 1 hits right there. So there we go, I found my other vertices. So my triangle's right here, guys. Okay, so my vertices would be 1, 2, 3. So right here I have over 1, up 3. Here I have -3, -1. And then here I have 3, -5. And there we go. Okay, moving on. Okay, numbers 19 through 22, it says order the angles and sides from smallest to largest. Okay, here we go. Well, the sides will be easy. AB is the smallest, and then BC, and then AC. Now the smallest angles are all, the smallest angle will be across from the smallest side. So angle C would be here's the smallest side right here. Go straight across. Angle C is the smallest. And then go to side 9, go straight across. Angle E would be the next smallest. And then angle B would be the biggest. Okay, moving on to number 20. Okay, the smallest side would be FE. The next smallest side would be DF. The next smallest side would be DE. And then now the smallest angle would be across from the smallest side. So here's 23. So the smallest angle would be D. Okay, the next smallest side would be DF. So go across from that, angle E would be next. And then the next smallest side would be DE. Where the longest side is DE. Go straight across, angle F. And there we go. Moving on. Number 21. Okay, let's see here. These two angles when added together is 120. So this angle here is 60. So my smallest angle would be H. My next smallest angle would be I. And then my largest angle would be G. Okay? So the smallest side would be across from H. So IG. The next smallest angle would be across from angle I, which is GH. And then the longest side would be across from angle G, which is IH. Okay? I'm moving on to 22. Okay, this is 90 degrees. 90 plus 50 would be 145. So this has to be 35. So So here we go. The smallest angle is angle L. The next angle would be, the next smallest angle would be angle K. And then the next angle would be angle J. So the smallest side would be across from angle L, so side JK. And then the next smallest or shortest side would be across from angle K, which is LJ. And then lastly, we have the side across from angle J, which would be LK. Okay, and moving on. Numbers 23 through 26. This is these are really good problems here, so please pay close attention, okay? They give you this right here, and they want you to see what conclusion you can come up with. Okay, so we know AC is congruent to BD. So here's AC, here's BD, okay? They're congruent. Now we know this side here is congruent to itself. You know what? I think it'd be better, students, I believe, if I do this. This is how I'm going to do it. It'll take me about 20 seconds here to do this. Maybe a little longer. Okay, so this would be A, C, D, and this would be A, D, B. All right, here we go. Now, we are told that AC is congruent to DB, and we also know this side here is congruent to this side here because they share that side right here. Now, we're also told that angle CAD, this angle here, is smaller than, we'll call it 40, is smaller than ADB. So we'll call this 50. Now what conclusion can we come to? Well, students, look, we have two sides of a triangle congruent to two sides of a triangle. In the included angle, we have an inequality. This angle is bigger than this angle. So we know this side here is bigger than this side here. So AB is bigger than CD. So AB bigger than CD. Here it is. AB is greater than CD, or CD is less than AB. So letter D. Alright, here we go. AB is congruent to CD. So AB right here is congruent to CD right here. AC is greater than BD. So we're going to say this is 8, and we'll call this 6 right here. Okay, this side here is bigger than or greater than this side here. Now we know this side here is congruent to this side here. Now look what we have, guys. We have two sides of one triangle congruent to two sides of another, and the third side here is longer than this side here. So we know this angle here has to be bigger than this angle here. Okay, so what is this angle here called? CDA is greater than, what is this angle here called right here? DAB. They might call it ADB. Let's see. No, DAB. Now, if you'll look, this angle called CDA, they called it angle ADC. Same thing, okay? Same thing. So here it is, letter B. Okay, moving on. AB is congruent to CD. So put a slash here and a slash here. We know this side here is congruent to this side here. Angle CDA, this angle here, is less than, we'll call this 20, is less than angle BAD. BAD. So we'll call this 30. So same thing, guys. We have two sides of one triangle congruent to two sides of another triangle, and look at the included angles. this included angle here is bigger than this included angle here. So the side here is larger than or longer than this side over here. So we have DB is greater than AC. Let's see if we can find that anywhere. Here it is. AC is less than BD, or BD is greater than AC. So letter A. And there we go, moving on. Okay, last one. AC is congruent to BD. We know this side here is congruent to this side here. AB is less than CD, so we'll call this 10, and we'll call this 12. So again, students, look what we have two sides of one triangle, congruent to two sides of another triangle, and the third side, this side here, is greater than this side here. So this angle here has to be greater than this angle here. And what is this angle here? Well, it's called CAD. I think they call it CAD is greater than angle, and it would be this angle here, which is ADB. Okay, and here it is right here. Okay, they have ADB is less than CAD. I have CAD is greater than ADB. Same thing. Okay? Alright, moving on. Number 28. You're designing a circular swimming pool for a triangular lawn. You want to find the center of the pool to be equidistant from the three sidewalks. Explain how you can locate the center of this pool. Okay, students, listen to me carefully on this, okay? You want the center of the pool to be equidistant from the three sides. That means perpendicular to the sides and equidistance, okay? Now, listen carefully, okay? We learned three things. We learned 3 points that are called points of concurrency. One was a circumcenter, one was an incenter, one was a centroid, and one was an orthocenter. Only one of those points is known to be equidistant from all three sides. And that point is called the incenter. Okay? The incenter. So, what three lines can you draw that give you an incenter? Well, hopefully you know this. Guys, it's the angle bisector. Okay, when you draw three angle bisectors, lines that cut the angles in half, they're going to intersect at this point right here. Okay? So how would you find the center of this pool? You would draw three angle bisectors. There we go. Pretty simple. And that's why it's so important, guys, that you know these 4 points of concurrency and their definitions and what they mean. Okay? Alright, number 30. Okay, you want to rope off 2 sides of a triangular swimming region. The unroped side is 200 feet long. You have 600 feet of rope, and you want each side length to be a multiple of 50. What are the possible lengths of the sides? Okay, well, here we go. So basically, students, here's what they're saying, okay? There's an unroped side along the shoreline that's 200 feet long. So it looks something like this. Here's the shoreline. Okay, and then you want to rope off a triangular section, I guess, on the land here. So there's no rope right here. Okay, no rope for 200 feet. So your 600 feet of rope is for this side here and for this side here. Okay, so these 2 sides here, we'll call them X and Y, have to add up to what? 600. Okay, they didn't really write the problem very well to explain that. And they also didn't say that you have to use all 600 feet, but you do have to do that, okay? All right, here we go. So here's what I'm going to do. I have a side of a triangle called what? 200. I'll call my other side X. and my other side y. So I'm going to write this down. I'm going to write x plus y has to equal 600. When I add these two sides together here, 200 plus x, it has to be what? Remember, it has to be greater than y. When I add these two sides together here, they have to be greater than x. So 200 plus y has to be greater than x. Okay, so all of this has to be true. Okay, so here we go. Now, I'm going to put a column here of x and y. Now, students, I'm going to start with something really small, like 50. So if x is 50, y has to be what then? They have to add up to 600. Now, this won't work, guys. Watch. If I put a 50 here for x and a 550 here, I do not get true statements, okay? It doesn't work. It's not even close. Look, there is no way that 200 plus 550 is greater than 50. So this will not work. Will not work. In fact, let's just go ahead and let's skip some and jump up a lot more, okay? Let's jump all the way up to, I don't know, 150, okay? So if this is 150, then this over here has to be 450 to add up to 600, okay? So with the x's, I'll put 150. With the x's, I'll put 150. With the y's, I'll put 450. And again, guys, there's no way this is right. Look, there's no way that 200 plus 450 is greater than 150. It's not going to work, okay? So let's go ahead and try 200, okay? And this will be 400, okay? And I don't think this is going to work. It might. Let's see. 200. No, it's not going to work. But you know what we found? We found kind of the breaking point right here. Okay, there's no way that 600 is greater than 200. Okay, so let's go ahead and try something else here. Let's try 250. So 250 and 350. Okay, all right, here we go. 250 here, 350 here, 350 here, 250 here, and it works. Look, guys, it works. 450 is greater than 350, and 550 is greater than 250. So it works. So we're good. We found one side. Okay, let's try another one here. Okay, students, so that's good. We'll circle this one here. All right, let's go on to our next increment of 50. Let's try 300 and 300. Okay, let's see here. 300 here. 300 here, 300 here for y, 300 here, everything's good. 500 is greater than 300, and 500 is greater than 300. So we're good. Okay, let's try another one real quick. Let's try 350 and 250. And I think we already have that one right here, so it should be okay, I believe. Let's check and make sure here. 350 for x, and 250 here, and it should be fine. Okay, and yes, it is. Totally good. All right. Okay, moving on. And students, the next one we come to, I think is going to stop working, I believe. Yes, it is. So the next pair that we would use would be 400 for x at 50, and then 200 here. And just trust me, that will not work. So we're done. That's as far as we can go. Okay? So the answer would be triangles that are 200, 250, 350. We have that answer right here. And then 200, 300, 300. We have that answer right here. And remember, students, this answer right here is the exact same one as this one right up here. Okay, so there we go. Okay, all right, moving on to number 37. All right, number 37 says to hold on one second here. Do the points form a triangle? Why or why not? So here we go very quickly. do these points form a triangle? Now, guys, think about this for a second, please. Any 3 points, form a triangle. I don't care how almost they line up in a straight line. As long as they don't line up in a straight line, then you have a triangle. Okay? So anytime you have 3 points, they always make a triangle. Always. As long as those 3 points are not what? Collinear. Okay? So the best way to do this problem is just find the slope of AB, find the slope of BC, and find the slope of AC, and make sure all 3 slopes are what? Not the same. Because if they have the same slope, then they have to be collinear. They have to lie on the same line. So here we go. AB, y minus y, x minus x, 4 over 1, 4. Okay, number BC, y minus y, x minus x, and then AC. And so we do not get out the same slope. And so students, we know for sure then that these 3 points here, A, B, and C, are not collinear. Thus, they have to form a triangle. So yes, these 3 points do form a triangle because none of these slopes are the same. Thus, all 3 of these points are not collinear. Okay? All right, moving on. Numbers 41 through 44. Now, students, on 41 to 44, you're going to match a possible length, like 21, with the proper side of a triangle. Now, listen, more than one answer works for different numbers. However, they only want you to use one answer, so you have to use the process of elimination. Okay, let me show you what I mean, okay? Okay, for this side here, if we have 21, if we have the sides 4, 4, 21, add up your 2 smallest, and they have to be greater than the third side. 4 plus 4 is not greater than 21, so A would not work for this one. Now let's try 2. We have 2, 4, 4. Add up your 2 smallest sides, and that is greater than this side here, so 2 would work for 41. Now let's try 6 with 4 and 4. So we have 4, 4, and 6. Add up your 2 smallest sides, and they would be greater than your third side. They would be. So we could also use point C. Now let's go on to point D. 9. 4, 4, 9. That would not work. Add up your 2 smallest sides, and they are not greater than your third side. So this would not work. So here we have B and C for possible answers. Okay, let's come over here. Let's use 21, 2, and 3. That's not going to work. 2, 3, and 21. Your 2 smallest sides, 5, are not greater than your third side. So A would not work. Let's try B. 2, 2, 3. Well, 2 plus 2 is greater than 3, so we're good. So B works. Now let's try C. 2, 3, 6. That would not work because 2 plus 3, 5 is not greater than 6. Okay, so we know C is not going to work. Let's try D. No, D is not going to work either. 2, 3, 9. 2 plus 3 is 5. 5 is not greater than 9. That's a really big help. The only answer that works here is B. That's the only one. So we know that B cannot work over here. Okay, you can only use each answer once. So this is C, and this is B. So now we're just left with A and D. Okay, so let's try A over here. 21. Let's try 9, 11, 21. That works. 30 is greater than 21, so A works. Let's try D. D also works. 9, 9, 11. 18 is bigger than 11, so D also works. Let's try this over here. Let's see if A works. 5, 18, and 21. Yep, 23 is bigger than 21, so A works. Now let's try D. 5, 9, 18. No, D does not work because 14 is not bigger than 18. So the only answer that works here is A. So if A works here, then A cannot work here. So we have D and we have A. Okay? Hope that helps, guys. There's your answers, okay? Alright, moving on. The centroid is the intersection of the altitude of the triangles. Well, guys, sometimes it is. Now listen to me, okay? Because we know the centroid is the intersection point of the medians. Now listen, the centroid is the intersection of the medians. So you're probably saying, Mr. Earhart, how can the centroid ever be the intersection of the altitudes? Well, guys, if we had altitudes that were also medians, okay, like this, how would that be? Let me think that through for a second. Okay, if we had an equilateral triangle, and I do the altitudes, well, guess what? The altitudes would also be the medians. So in that case there, because the altitudes are also the medians, then this point here would be the centroid. So yes, it sometimes can happen. Yes, when your medians are the exact same thing as your altitudes. I hope that makes sense, guys. Okay, the centroid is the intersection point of your medians. Okay? Now, since that's true, the only way that the centroid can be the intersection of the altitudes would be if your altitudes were your medians, and that happens in an equilateral triangle. So sometimes. Okay, number 46. The angle bisectors of a triangle intersect at a single point. Well, guys, we know that's true. We've learned that. Anytime you draw the angle bisectors of a triangle, they are concurrent. They will intersect at one point. So always, yes. Okay, 47. The mid-segments of a triangle intersect at a single point. Well, guys, the only time I would think that might ever happen, ever, is if you had an equilateral triangle like this. So here's this. Okay, and then here's this here. And then here. It's never going to happen, guys. Okay, there's no way you can draw a mid-segment and those lines will intersect at one point. And I'll tell you why. Because this point here is the midpoint. It is going to be on this line here. But it also has to be on this line here. So if these two lines here, this one, and this one intersect here, which they do, how could they intersect somewhere else also unless this line bent and curved back around, which it can't do? Okay, so no, your mid-segments would never intersect in a single point because they already intersect right here at the midpoints. Okay, number 48. The length of a median is equal to the length of a mid-segment. That's interesting. I've got to think about that for a second. I would say it does. I know for sure it doesn't have to be true, but I would think it's possible sometimes to be true. Yes. Let me try to think of an example for you. Okay, here would be an example, guys, where a median and a mid-segment have the same length, okay? Start off by drawing an equilateral triangle like this, okay? Now, go ahead and draw your median from here to the midpoint. So that's your midpoint right here. And don't forget that that's really important, okay? So there's your median. Now, here's your mid-segment from here to here. There's your mid-segment, okay? Now, right now, those two segments are obviously not the same length, okay? However, if I were to take this side here, think about it, guys. and start swinging it like this and moving the side out along this dotted line. Okay, this point here, this line here would grow as this one did also. Okay, now this one would slide up a little too. That's true, but this one would grow at a faster rate. So as you took this point here, okay, this point here, now watch this, and moved it along this dotted line, okay, and the side of the triangle here kept changing and spreading out, and the triangle became bigger and bigger. This line here would grow to stay with this point here, and eventually this line here would at one point be the same length as this line here. Okay, and so yes, sometimes, not always, and not never, but sometimes it is possible to have a median that has the same length of a mid-segment. Okay, all right, continuing on. Actually, we'll stop here and we'll call this part 1, and I'll make a part 2 for the next video with the next part of this review sheet.